Ever wondered how machines can predict, classify, and make sense of complex patterns in data? Welcome to the fascinating world of support vector machines, or SVMs, a potent tool in the machine learning arsenal. To begin, picture an SVM as an intelligent artist. Given a blank canvas, this artist's job is to draw a line or a plane that neatly separates different groups of data points. These groups could represent anything from email spam or not spam to creditworthy or non-creditworthy loan applicants. The artist's masterpiece, the line or plane, is what we call a hyperplane in SVM terminology. But here's the catch. There could be countless ways to draw this separating line. So how does our smart artist decide? This is where the magic of SVMs comes in. SVMs don't just draw any line, they draw the best possible line. The best line or hyperplane is the one that maintains the maximum margin or distance from the nearest data points of all groups. These crucial data points are our support vectors. The wider the margin, the better the hyperplane, as it ensures a clear distinction between groups and reduces the chances of misclassification. Now, not all data sets are as cooperative as we'd like. Sometimes they're so entangled that drawing a line or plane to separate them in their original space is impossible. This is where the kernel trick comes in. The kernel function can transform the data into a higher dimensional space where separation is possible. Imagine lifting a tangled thread off a table and finding that it untangles in midair. That's what the kernel function does, but in a mathematical way. But of course, SVMs aren't perfect. They can be sensitive to the choice of the kernel and its parameters. If these are not chosen carefully, the SVM could overfit, or in other words, perform well on the training data but poorly on unseen data. Also, SVMs can be computationally expensive for large datasets, so they're not always the go-to method for big data problems. To wrap up, SVMs are powerful machine learning algorithms that find the hyperplane that separates different groups of data points with the maximum margin. They cope with more complex scenarios using the kernel trick, but require careful tuning and may not be suitable for large data sets. Remember, SVMs are just one tool in the machine learning toolkit. Choosing the right algorithm for your data is an art as well as a science, and understanding the strengths and weaknesses of each tool is crucial. The world of machine learning is vast and ever evolving, so keep exploring.